Now we're going to go from 5-axis to hole making because we've added a new method, new hole type method, and that is called rigid tapping. Now, rigid tapping, if your CNC controller supports what we refer to as canned cycles, C-A-N-N-E-D, as in a can. So these are predefined cycle types in your CNC machine that you can apply as needed. So this is an additional cycle type that we've added. It is a G84 cycle. And what we're doing here is if you're unfamiliar with rigid tapping versus regular tapping, so basically the difference is in the tool itself. In rigid tapping, the tool is rigid. In other words, the holder, the thread, everything is one rigid unit. Okay, so the movement of the threading, the cut feed, and the Z-dip is all controlled in the spindle and in the cut parameters that you're outputting. Okay, I should back up and say that. I should reword that. If you're using the rigid, then if you look at the can cycle over here, it outputs the requirements for the controller to calculate the feed rate, the cut, and the
RPM is most important, the spindle RPM.
Yeah. So in the regular tapping, the tool is actually a floating tool where it does I guess the tapping inside that floating area. But there's one thing you need to know about this. The rigid tapping is a lot more accurate. Okay. And but there is one thing you want to be concerned about. Because it's rigid, you want to make sure you got your parameters correct because it puts more stress on the tap tool itself. So Joe, you want to add any more to that? I know it was kind of awkward explanations, but
no, go ahead. I think it's too difficult to explain it by words, so you need pictures. So
okay. So let's just to recap there. In hole making, there is now multiple options for tapping, and I'll show you that one on this part. Okay, so you got a rigid tap, that's the new method, and then you had your previous methods, which was a regular tap, and we'll show you that. Okay, let's look at one more part. In this part, we're going to look at rigid tapping in hole making. So let's go, this is our last part, so we should wrap this up pretty quickly. So let's go down here. So what we have is a basic 2-axis part, and we've got this hole pattern. But what we want to do is we want to tap these holes using a rigid tap method. And in a rigid tap, rigid means that the tap tool and the collet on the tool is rigid. Okay, it's like one solid tool. And also I want to mention that the rigid tap is a can cycle. In other words, it's one of the cycles that's built into your machine controller. If your controller supports can cycles, then you can use these to do drilling, tapping, boring, etc. Those are all can cycles that's built into your router that we can take advantage of when we post out to the G-code itself. So what do we have here? We have a rigid tap cycle tool path. Let's take a look at what it looks like. So we're selecting the 4 holes. Okay. We're using a rigid tap tool. Let's take a look at what that looks like. Okay. So this is our tap tool. The pitch is 0.041. Okay. And it can be a single thread tool or a multiple thread tool. Okay. I believe either way it should work fine. And this is the critical, as we did in thread milling and looked at the thread milling tool, the tap tool. Your thread pitch is the most critical dimension that you need to make sure you meet. Obviously, your tool diameter, etc., needs to be match the threads that you're tapping. But that should all be taken care of if you buy you know, what is this, a 3/16 or 188 tap tool or 3125 tap tool. All those dimensions will be in your spec sheet for the tool itself. So there's the rigid tap tool. And what the difference is here on the cut parameters tab, you'll now see that you have a rigid tap selection in the tapping types that you can pick from. So we have a tap, a PEC tap, a rigid tap, and then tap 1, 2, 3, 4, which are user-defined cycles that you can define yourself. What we're talking about here is a rigid tap motion. So we're going to pick rigid tapping. The depth is 1/4 of an inch. The location of cut geometry is at top. Okay, the curves are at the top of the hole. The dwell, we have it set, we have it turned off. And for the tap direction, we're doing a right-hand thread. We have an approach distance of 0.2, which means that the tapping tool is going to come down to 0.2 above the geometry, and then it's going to start tapping. And the feed rate is going to start going down on the z-axis to do your tap. Okay, so let's take a look at, let's cancel that out. Let's take a look at what happens in the post. So we got Haas rigid tap. Let's take a look at that. You'll see that down here in the cycles section, these are all of your canned cycles. Okay, if your machine supports canned, as in a can, C-A-N-N-E-D, canned, so you have canned cycles. If your controller supports canned cycles, you'll be able to take advantage of all these different operation types in hole making. So here we added a rigid tap motion, and we have set up the cycle code here for a G84. All of this has been added in to create the G84 line of code, the CAN cycle code to post out to your router. If you don't see, this is not in there automatically in your post. If you want this added to your post, just contact us at support@MecSoft.com and we'll update the post for you. Okay, and let's see, that looks good. So let's go ahead and close that and post this out. Let's cancel that. Let's post. Okay, so we have 4 holes. We have a G84 CAN cycle that calls the CAN cycle on the controller. Okay, so you got 4 of them, and this is the line of code for your CAN cycle right here. Okay, so it's a G84. This is the X and Y location, the Z depth. Okay, this is the 0.2. This is the height at which the tap starts tapping, and then of course we have the feed rate of the tap itself. So this is one line of code that's posted out now that you can do for rigid tapping. Okay, that's it for the demo.